Okay, guys. Uh, I am excited to be here, and this is my first time in Meetups. Actually, Olga invited me, and I'm super excited to be presenting this talk. So I hope everyone is staying positive at home, having fun. I've been more relaxed, like working more relaxedly from home. So it's been an experience here. So I'm going to take the time to thank BML YNR for the opportunity of me bringing ideas with my experience. So I'm going to thank also my team. They've been very supportive with me. So wanted to do that. And I'm going to briefly talk about me. Basically, I am a QA engineer. I have 9 years of experience. Right now, I've been working with frameworks such as C Sharp, Java, a robot framework, and I am from Mexico. I've been participating in projects in Mexico and in USA. The last couple of years, I've been working a lot, contributing with DevOps teams, configuring CI CD pipelines. And I think there's where I learned the basics and kind of deal with Docker containers. So I want to share that with you. Feel free to ask questions or interrupt if you want, if you have something. Okay. The overview, I'm gonna give the concepts, what Docker is, what it does, the benefits, the importance, and the basically focus on testing. I'm gonna talk about we're gonna run a Docker container manually. I'm gonna go and show my terminal, and I'm gonna run the command lines so you can have a better idea about it. Basically, we're gonna install the dependencies on a container, and then we're gonna copy an automation framework from our local host to a container. Yes. So the third part is after we know how to do this. I mean, we know all the dependencies and all the command lines we need to for our container. We're gonna use Dockerfile and we're gonna build an image. And at the end, if we have time, I'm gonna run Docker Compose and Selenium Hub. Basically, with this, we can create our own network with containers. And this is to run Selenium frameworks in parallel or with any need of local web drivers. So let's think about the following scenario. You're testing an application that requires Git, Ruby on Rails, Python, just to name a few dependencies. Let's say several testers are working on this project too from different locations and using different operating systems. What challenges do this situation present? First, testing environments will be troublesome as you don't know what operating system each tester is using. Then you will need to pull the source code and install the dependencies such as libraries on your local system. All of those can cause issues with the different versions and administrative grants for some of them. So how can we go about this without depending on a physical environment that you cannot control all the time? Here is where Docker comes in handy. In response to these kind of situations, you may have already heard that containers are currently dominating the field of application development, especially in cloud computing environments. So let's take a quick look at the Docker concept. Docker is a set of platform as a service product that uses operating system level virtualization to deliver software in packages called containers. Containers are isolated from one another and bundle their own software libraries and configuration files. They can communicate with each other through well-defined channels. This may not make much sense to you right now, but as we go into the practice, you will see how it connects, and it's going to make sense very quickly. So just bear with me for now. Okay. Why Docker is important for our testing practices. So what to the benefits of using Docker, there are several. First off, it allows for both QAs and developers to work in the same environments, which can ultimately prevent delays in deployment, as you don't have to waste time in pesky configurations. Then reporting is made easier, as instead of just reporting errors or bugs, you can share actual images of the application in real time. Although we won't focus on very much on that today. Lastly, as everyone in the delivery chain can work on the same environment, the process can remain consistent, which will ensure the quality of the end product. We all been in situations where we receive something from the developer and we cannot readily access to it because we have a different configuration. But the image illustrate Docker eliminates those issues and allows you to get to work more quickly. So far, are we in the same channel? Any questions? Can you guys hear me all right?
Yeah, we can hear you.
Okay, perfect.
Great.
Doing good.
Excellent. Okay, I'm not going to go to all of the benefits of Docker, but you may heard that another option is virtual machines. In my previous projects, I've been working using virtual machines to have access to the source code and to set up the environment. But you can see here that Docker is lightweight. I mean, performance is better, and Docker is gaining popularity as almost we know about it. I mean, on the continuous integration environments. So you're gonna see how easy it is for you to. I mean, if you are using your operating system is a Windows, then you can easily raise up a Linux version, and I will demonstrate that in a second. Okay. Okay, now I'm going to talk about the container and Docker image. These are the one of the most important elements of Docker. A container is a software package that consists of all the dependencies required to run an application, and an image is a set of files which has no state, whereas Docker container is the instantiation of Docker image. In other words, Docker container is the run instance of an image. Okay. What we're seeing here is what I just described, the Docker image, the Docker container. You can see in the right side, Docker Hub. Docker Hub is where we can get public images, and basically based on our requirements or in our needs, based on our needs, we can go to Docker Hub and pull images. And once we have our base image, then we can, based on that image, we can create a Docker container, as you can see below, in the below rectangle. And the left side Docker file is something that is basically it will install the required dependencies once we have the image. So I will demonstrate that in a moment. Okay. I wanted to mention that the images, these are some of the distributions of Linux that we have on Docker Hub. So basically on this demo, I'm going to use Alpine images. Why I'm going to use Alpine images? Because you can see the size. And Alpine, the size is almost 4 megabytes versus 100 and plus. So basically, if we are going to use these types of images in our continuous integration environment, the performance is better working with Alpine images. Okay, so I think I can start with the demo. Did you guys have any questions so far? Also wanted to mention that on the comments, I have placed the link where you can access to the command that we're going to execute today. So you can go there and start executing this. So let's start. First of all, the first scenario that I'm going to run, it's basically, let's suppose we need an environment where we need Maven installed, Java, and Git. And we also need a framework that runs with Selenium. So in this case, I'm going to use Serenity VDD. So let's suppose in your local system, you don't have any of these dependencies. So we are going to create a container that will have each of these dependencies for us to run our framework. So the first command we're going to run is docker run. Basically, docker run is the command that takes the image and makes it a container. So you can see the structure here, docker run. The -it means that we're going to run it in an interactive mode. When I say interactive, is that we're going to access to the container, and then we're going to run, we can run the necessary commands to install Maven, Java, and Git. So first, I'm going to open my terminal. If you are on a Mac, you just open your terminal. If you're on Windows, just open CMD, and we're on this command. Basically, Alpine is the base image we're using, and the last bin -sh means the entry point. For example, here I'm using shell, but sometimes we use another structure such as bin bash. So these can, I mean, in this case that we're using Alpine, it runs with shell, but sometimes there are images that run with bash. So in this case, I'm going to run this one. Basically, what this command is doing is pulling the Alpine image from Docker Hub. And you can see that now we're inside the Docker container Alpine. All right, so if I do an ls, basically I'm not in my local system. I'm right now inside of the container. All right, so the next step, we're gonna run these 5 commands. APK is the tool that uses Alpine to update or install software or dependencies on Linux. So basically, I'm going to run all of these ones. I'm just making sure that I'm updating APK because sometimes you need to update it. Okay. Then I'm going to install Maven. Also wanted to mention that when we finish executing all of the dependencies and when we have everything in place, we can push this image to Docker Hub, and then everyone is going to have access to this. So this is a very helpful way for if you have an AQ team or a QA team where you needed for them to have some dependencies installed like Python or any other library. You can create your image and then share this image with them. So I'm going to show that. So right now we have installed Maven. I'm going to install Java. Okay, Java has been installed. Oh, sorry. I needed to fetch it first. Now I'm going to install it. Okay. Okay. Then I'm going to install Git. So right now we have our container that has Maven, Java, and Git. So if I do Maven, now you can see that Maven, we're seeing the version. So we have everything that we needed. We just need to get the framework in place. So what we're going to run is we're going to exit the interactive mode. So we're going to exit the container. So right now I'm now in my local host again. So for us to make sure we have the container, we can run this command docker ps. Basically, docker ps lists the containers that are in your repository. But why we're not seeing any? Because docker ps only shows the one that are running. In this case, we need to run docker ps-a to see the ones that are attached. And you can see that this is the one that we just installed the dependencies 36 seconds ago. But why it wasn't showing before? Because this one is not running right now. So what I'm going to do now, you can see I'm gonna move to where I have my framework. I have downloaded this framework, and I'm going to open the terminal from where I have this demo framework. If I do dir, then you can see that here I have the files of the framework. Then I'm going to run. I'm going to copy my framework inside of the container. So to do that, we can run this command docker cp, and then we need the ID. Okay, do that. I need to make sure I include the specific ID for the framework that I have installed the dependencies before. And here where it says \home, basically I'm gonna copy all of these files inside of the container. So we can play around if we don't have if we're in an environment where we cannot install dependencies or install software, but you have access to Docker, you have this possibility to play around and install dependencies in containers, and that makes life easier. Okay, I'm gonna run this. So right now I have copied the code inside of the container. But if I want to access again to this container, what I need to do is I need to start the container again because we have exited and this one is not running anymore, so I need to start it. Okay, this have started our container, and then I can access it again with Docker exec, and then interactive. We're gonna run it in interactive mode, and then I'm gonna copy this ID. All right. What is the difference between Docker exec and Docker run? Remember that the first command I ran was Docker run because we were getting the first image from Docker Hub. So basically, when I ran the Docker run, it initialized the container. So it made the image as a container. But now that I have the container, I need to run Docker exec to access and to run in an interactive mode. So on this. Okay, so basically what I have done is I have copied the code inside of the container, and we previously have installed all the dependencies. So I'm gonna demonstrate that we have the code inside and that we still have the dependency. So if I do Maven version, I have Maven installed. And I also remember that we have copied it in the home folder. So I need to cd to home. This is optional. I mean, you can specify any folder. I just have assigned home, but you can specify any other path. So I'm inside of home, and if I do ls, you can see that I have copied the framework here. That basically, if I do cd here, here we have, and because this framework requires Maven and Java, actually I can run it. I'm not gonna run it because it's gonna fail. Why it's gonna fail? Because the WebDriver cannot run in a Linux version. So if time permits, I'm gonna show that at the end that I can raise a Docker container to run it with Selenium read to solve this issue. But for now, I'm gonna exit this container. If I do Docker ps, this is the one that that I have just copied the code right now. So what's next is, this is optional, but we have everything that we need in our image. So right now I can push this image to Docker Hub, right? So I'm gonna do that. So for me to convert this image into, this container into an image, I need to commit the image first. So before doing that, make sure you have previously created an account in Docker Hub and log in. So you just do Docker login. It's gonna ask you for the credentials. Okay, I have logged in, successful. Now I'm gonna commit the image. this command is going to convert the container into an image. Because if I list the images that I have available, I doesn't have this image, the one that has the dependencies. This Alpine is a different one, but this one is the one that I'm looking for, that has all the dependencies. All right, so for me to have this container as an image and then I can push it to Docker Hub, I'm gonna run the docker commit command. And I'm going to copy the ID, and then I can name it as any name that I want. In this case, I will name it Maven Java. I'm not sure, 1 or something. So all of what we have installed now has translated into an image. The Maven, the framework. So if I do Docker images, you can see that now I have the Maven Java 1 that we just created based on our container. And then I should be ready to push this image Docker Hub. So all of these commands, you can execute them later if you don't have Docker installed in your system. You will find all of these commands in the URL I shared with you previously. Okay. 1 second. Okay, Docker tag. Okay, after we commit it, we need to tag the image and then push it. So let me quickly go ahead and open my Docker Hub so you can see how it looks. Okay, these are some. This is my repository, and these are the images that I have worked before. Some of these ones has Ruby and stuff like that. So I'm gonna make sure I push Maven so we don't see Maven here, the one that we just created. I just wanted to show how it looks before and after. This is the name of my repository, Memetronic. So let's execute the next command, which is the tagging. So we need to put the image name. And then I need to put the name of my repository, the one I just showed you, and the name that I wanted. In this case, I will name it the same, Maven. This is just for demonstration purposes. So Maven Java 1. This is the name, how it will look in my repository. Oops, sorry. Okay, and now I'm ready to push this image. Docker push, and I need to push this. Okay, I'm not gonna wait until this finish, but once this process finish, I will be seeing that image published, and anyone can have access to our just created image from, I mean, if they have Docker installed, they can do the Docker run, the first command we run, Docker run interactive mode, and they can do mem and then backslash maven java 1 and do bin bash, no, sorry, bin sh. And if they run this, anyone can have access to that image. So in case we have a QA team split it in different places and we don't have the same dependencies and we have different configurations. Some of them have Mac and some of them have Windows. In this case, if they only have Docker, we can have all the same Docker image that we can use to execute our automation. So basically that was the demonstration manually. But the good thing about what we just run is that there's an automatic process for that, and that is called Maven build. And I'm going to show you how to do that. Okay. Then you need to open this one, the second section. All right. Okay. Now I need to CD again where my framework is located. So I'm gonna CD here again and make sure I am in the right place. Okay. Then the second step, to make all the process we just did, instead of doing it manually, we can create a Docker file. So I'm gonna create a Docker file here. You just put it inside of I mean, in the base code. Why we're putting the Docker file here? Because I'm gonna show you in a second. We name it Docker file, and then I'm gonna explain really quickly what we're doing. Remember that we run the command Docker run, where we were using Alpine as an image. So basically, this is doing the same thing. You can use any image that you want, any Linux distribution, Alpine, CentOS. There's a bunch of images in Docker Hub. So you can go and search based on your needs. And we just do from Alpine. And once we do this, after that, then we can start installing our dependencies. Instead of doing that manually, we can use just this syntax, for example, run, and you can see that I'm running the same commands we ran before. We're installing Java, Maven, and what this command is doing, the copy, the dot that you see here, that you may see, basically the dot is copying all the files from that directory and pasting all of them in home. That was the same thing I did manually. And once it finished, I'm gonna show what happens. So first, I can copy this into my Docker file. These are just comments. I can leave them or delete, doesn't matter. I'm gonna save this. Okay. I make sure I'm inside of the automation framework. Now I have the Docker file. And then I'm gonna run the following command to make that happen. the command is docker build. The dash T means tagging. So in this case, the tag is for us to put a name to our container. And the dot means that we're specifying the Docker file that is located in that current location. Docker build dash tag. And let's name it Java, Java 2. Then a dot. Basically, this command is gonna take the Docker file we just created and execute. It's gonna pull the image from Docker Hub, and then once it pulls it, then it is gonna run all the commands, and it's gonna generate our container. I mean, not container, it's gonna generate automatically the image. So let me run this. Basically, this is executing the same stuff we did before manually. So some ideas that I can give you is that if you are provisionally using some libraries such as Python or Ruby on Rails, and you don't want to install all of that in your local system, you can create your environments easily just running these commands. Instead of running Maven, you can run Python, or if you need some bin files, you can copy them from your local, or you can install Git inside of a container and you can pull some code from other sources. So this is the benefit of the testers to be able to create any environment without the need of a virtual machine, without a need of, and this makes things very portable. So once you create, that's why we're in a development environment. Developers just provide us the image. We just pull the image, and then we can install our frameworks in the same image and run our automation. So that's the cool stuff that using containers. Any questions so far? This is gonna finish in a second.
Hey, I guess while we're waiting for it to install, my question was earlier when you were doing fetch and adds to add in things like Java and GitHub or Git support.
Mm-hmm.
I noticed that you didn't include any kind of versioning on there. Is it possible to try to add or fetch older versions in case we need to, like, for
Yes.
example, like test an older bug
Mm-hmm.
or test an older environment?
Exactly. Yes, you definitely can install any version. I mean, any possible version depends on the Linux version. But yeah, for sure. In this case, I have just, I mean, I just took some basic frameworks. But yeah, you can install any version. I mean, there's
Okay,
a
so
bunch of commands.
there's a way to
Of
version
course,
and
if
add.
yes, yes.
That's awesome.
Maybe in
Cool.
another
Wonderful.
set, in another version, we can recreate any environment. I mean, if someone brings some scenario, we can create it or stuff like that for sure.
Wonderful. Thank you. Yeah.
Sorry for this taking too much time. I think my network is kind of slow, but almost there. It is on the 38. We just need 2 more. I'm gonna take a drink to my beer. Just drinking juice. Olga, how much time do we have on this session? Do we still have 10 more minutes?
Yes.
Okay, good. Almost there. I just want to wait for it to finish so we can also know how to push these images, but now using Docker build, which is a lot way easier than doing it manually. So I would, based on the previous question, I would say running containers manually will be a good way for you to know the specific commands you're going to place in the Docker file. So in case you need some specific versions, you're going to first make sure you are able to do that. Maybe you can Google all of those commands. And once you know, I think that's the importance of doing it manually. Once you have all set, then you list your commands and then you just paste them in the Docker file and you run a Docker build and that's it. I would say that's a good thing. Okay, so now that it's finished, if I do Docker images, you can see that we have the second image. So in this case, I can do the same thing like Docker tag. I mean, I don't need the commit. The commit is only when we do it manually. So in this case, I just need Docker tag. And I just put this name. I'm not gonna, push it, just wanna demonstrate that. And then if I have my repository, I can, and then I can do that and then push it. And then we can have an image published. So let me give you a quick anecdote here. I was working in a previous project and we were using SVN instead of Git. So my manager asked me to have an image with the latest version of the code, and I have used this process. Like I figured out how to do the SVN, and basically I was at that time I was able to have an image with the latest version, but using SVN. So what I did at that time, I have installed SVN in my container, and I have included the credentials, the required credentials, and I have included this process in the continuous integration. So basically, there's something that I want to quickly show you. I think almost all of you have this idea, but I just wanted to. I'm gonna open GitLab. I'm not sure how many of you have are familiar with GitLab, but GitLab is a CI/CD tool, and basically you can create your containers and images, and then you can set up your pipeline very easy. I think this is taking time, but I will try. So these are some projects. Very slow. Okay. This is the source code. But basically, how this works is you just create GitLab CI YAML. This is a YAML file you just put inside of your code. It can be an automation framework or stuff like that. And these have access to Docker Hub. So let's suppose you want to run your framework using your just created image. You can just call the image from Docker Hub. In this case, I just rename it and do the one that I have just created, and then start executing my commands. So basically, these commands are gonna run versus my code, base code, and then I can get the files or the reports and publish them. This works very similar to Jenkins, but I just wanted to show you what is the importance. So this is just a job. We can have like 7 types of jobs depending on what we need. So let's suppose we have 3 more scenarios. One, we're gonna run performance. We need that link with Java. So we create a container for that. Then on another one, we just need Java, and another one we need Python to run a front end in another one. So we can create several images, and we can just call them simply by putting the name here. So that's something that I wanted to highlight. And I think I'm good for now. That you guys have more time to show the Docker Compose stuff. What do you think, Olga? Are we still on time?
Um, we we're kind of close on time, but do you guys have any
Okay.
questions? I would just probably open to questions and see if everything that we went over is actually clear. I've actually learned a lot of new things today, so guys, if you have any questions, please feel free to ask now, and then we'll check on time again.
Yeah, my last scenario was I was trying to do Docker Compose. Basically, Docker Compose is using several containers running one configuration, but for several containers at the same time. So this is what illustrates. But I think that will take kind of another 30 more minutes. So I think we can maybe
We can
group
leave that part.
have a second session.
Yeah.
Sure.
Yeah.
Okay. Any questions? Anyone? Any comment?
Well, Emmanuel, so correct me if I'm wrong, but basically, a pretty good scenario for us in test automation is we can actually improve improve the process of onboarding, of executing the tests, onboarding new new people, and actually just transfer our project to any other system, any other person to execute. That would be the main scenario for using Docker in test automation. Just portability and the ease of onboarding and installation, right?
Correct, correct, yeah. And for one, I remember I was working in a financial project where I didn't have access. I mean, I didn't have grants to install any IDE or any library, but at that time, they had Docker. So with Docker, you can create any environment without needing to install any dependencies on your local. So at that time, I was able to run um, Node.js, Python, and Java, C Sharp. Well, not C Sharp, .NET, because C Sharp only runs in Windows environments. So that's kind of the cool stuff about it. That if you have an image with what you need for your project, you can just create it once, and you're not going to have the conflicts of dependencies and stuff like that. Yes, I will say that's a benefit.
Yeah, and you also can have it all versioned. The the Docker file, you can
Exactly,
store
yeah.
it in GitHub and
And
awesome.
also you have the possibility to use versions. So if you, for example, you have your base image, but you keep adding updates or different libraries, you will have the different versions. So in case you want to use old versions or new versions, you have that option. So that's pretty cool too. I didn't went through that, but it's easy. When you assign the name, you just put colon, and then you can put some tag there, and you will have versions. And so that's something that's pretty nice. And also in our testing, so for example, if we are working in an environment where the image is being deployed, the complete image, we can, instead of logging defects, we can provide the image that is having issues, and we can provide that one to the developers and let them know what the issue is by providing the version of the image instead of logging the defects. So also that makes things easier because maybe they are running a setup where the issue is not happening. And if you are detecting what's going on with the current image, that's something that adds benefit to it. So that's kind of another thing to point.
Yeah, awesome. I also wanted to mention
All right. Mm-hmm.
in one of our meetups, Andrea was showing the visual testing with Backstop.js and executing tests
Mm-hmm.
with
Oh,
that.
actually, oh, sorry to interrupt.
Yeah,
Mm-hmm.
yeah, go ahead. Go ahead if you had something.
I was able. Yeah, I think I can run that one and show the group what's another benefit of having Docker. You're talking about this one, right, Olga?
Yes,
Backstop.js?
yes.
Okay. Okay. I think that everyone has context on this one, but uh,
I'm
I'm kind of new on this framework. Mhm.
Emmanuel. I'm not
Yeah.
sure
So
if I
what
don't.
I
I'm sorry. Do you mind if I give a little bit of context because I think we have some people who did not attend that meetup. So I'll just
Yeah,
give some context.
yeah. Please go ahead. Mhm.
So the visual framework,
Mhm.
which is Backstop.js, it's now what it does. It's kind of a snapshot type of framework. So um, the tests that we're running with it, it's just going to the browser, loading up the website, the page, and then it takes a screenshot either of the whole page or of some element that gets specified in the framework. And that snapshot, that picture of it gets actually saved as a saved as your baseline, and then over time you can execute those tests to compare your new snapshots to the baseline, and it compares the images pixel to pixel. Basically, compares the bitmap images pixel to pixel. And the problem that we were running with executing those tests were that when we were developing our tests in our local environment, we would take the baseline screenshot in whatever operating system we were running on. Some people would do it on Mac, some on Windows. But then when we would have to run it in our uh, pipeline, it would be a completely different operating system there. So we were having all these mismatches where it would the test would be failing because there were, even though the browser is the same, it uses we were using the same browsers, but because of the operating system differences, the elements on the page would render a little bit differently. It's actually, as a human, we don't really notice those differences, but when comparing pixel to pixel, the differences were significant. So for us, it was really important to execute every time those tests in the same operating system. Okay, I think I think I caught
All
up
right.
everyone
Yeah.
on this.
Perfect. So I'm gonna go ahead and CD to where this project is located, and I'm gonna first run it locally on Windows, and we will see the issues that Olga just explained. So if I run Docker test, I'm gonna do the comparative of the pixels before and after, and we're gonna get the report that in a second. Hope not to take more time. No.
You'll have to run it again. I think it's the error that you were getting there. It basically it says that it was
Oh
not
no, I
successfully
think
launched.
I just ran it before the call, and it generated the report. You're gonna see it, and then I ran it with Docker, and all of the tests passed. So I think we will be able to show that in a second. Just let's finish. Okay, it generated the report. Now
Yep.
I'm gonna run it with Docker.
it's actually giving you a lot of errors, and it's not going to show a.
Yeah,
So it's
yeah.
not working. This is a very this is a very common
Sorry about
thing
that.
in
I,
automation, right?
mhm,
Sometimes it just doesn't
yeah.
work whenever you present it live. So, but you did have when you were.
Do you think this is the issue related of the credentials
No,
or
it's Puppeteer has
no?
encountered errors. No, it's
Okay,
navigation timeout. So it's
because I think I have in the historical I should have the other report.
yeah, one of the screens that you were showing, you did have. I did see a report where the mismatch was
Mm,
actually for the.
mhm.
Yeah, you can check it.
I think all of these ones pass, right?
No,
Because we didn't
I
see
those are.
because okay, you can see the word failed here, but yeah, I'm not sure. Maybe I can work on this to try to fix it. But
Yeah.
yeah, the last time I ran it, all of those passed with Docker, but it didn't pass with locally with Windows. So yeah, I think I will work on that to show
Yeah, that's
next
okay.
time because I'm
That's
not sure
okay.
what the issue.
I think
Hmm.
the issue right now
Hmm.
is that you're running a lot of applications on your machine, and
Hmm.
we're also streaming this, so maybe it's just too much for the system.
Yeah, maybe. Yeah. Sorry about that, guys.
It's okay.
I do have
All
a
right.
couple of questions.
Uh-huh.
I guess the first one
Yeah, go
is
ahead, please.
say you have a Docker container. Is it possible to clone that multiple
Hmm.
times to test in like in parallel the same instance? You know, does that make sense?
Yeah, for sure. Actually, remember I show you here in GitLab um, that we can have a pipeline. So for example, you can have, for example, 7 jobs where you run different commands and you can call the same image that
Oh,
all the
okay.
times that you want. I mean, yeah, so that's not an issue. That's a
As long as your computer can
good
handle it,
question. Yeah.
right?
Um,
Okay, so one
exactly.
person could
Yeah. If you have a good
possibly test.
processor.
Yeah. So one
Mm-hmm.
tester could test multiple instances and images.
I
Then right.
think
So
the issue I will say the issue can be if all of them are making changes and pushing that at the same time. That
oh,
might be
okay.
an issue. I mean, if they add, that might be an issue. If all of them are, I haven't been in that situation, but I think that will get some conflicts. I mean,
Okay.
if you are adding new libraries and then pushing that, yeah. But if you are using the base image, you can use them all the times in
Yeah, as long as
parallel
there's no
that you want.
conflicts. Wonderful. Okay,
Exactly.
that's
Yeah.
exciting. I guess then the follow up then would be, is there how complicated would it be to create a Docker that would manage other Dockers? Does that make sense? So like if you were to have I don't know, a one that's able
Okay.
to manage nested ones, nested containers inside of it, is that possible?
Yeah, actually, there's an image. I have used an image in GitLab that is called Docker inside Docker. So
Oh, okay.
basically, you can run Docker inside Docker. So that's kind of weird, and
Yeah.
sometimes you will get issues. But I think with Docker Compose, once we get to that point, it will be kind of more exciting because with Docker Compose, we can create networks and run Docker inside Dockers and connect. Yeah, I mean, kind of connect between them, have communication between them. But yeah, sure, that's something
That's
fun.
kind of scary, right?
Might be fun. Yeah.
Your Docker becomes
Yeah, but
self-aware.
thanks for asking. Exactly, yeah. But what do you guys think about it? I mean, have you guys used it
Useful
before?
tool
Do
for
we have
sure.
people that have experience with it?
I do not.
I have used it just for testing purposes. I haven't go deep. I mean,
Mm.
talking about deploying a complete I think the most complex thing I have done is that I have deployed some code using Ansible. So, but I haven't deployed a complete container, if I say so. I kind of just in the QA context at this point.
Wow,
I've
that's so pretty impressive.
yeah.
Yeah.
I've used Docker primarily with somebody else's images. Just pulling an image in Docker Hub. I was just searching for an image that I needed with a tool that I needed, and I would pull it. But I was thinking it was way too complex to just create your own image. But now I can see that it's actually pretty doable. It's not a not a big deal. We can do it.
Not as scary as it sounds, or as you seem like, or
Yeah.
you feel like it's going to be.
Yeah. It's like
That's
And
super
actually,
true,
for
yeah.
example, just oh, sorry. For example, the names of the images are pretty straightforward. Let's pull you one Maven. There's an image called Maven. You just do. Some of them I know them. I mean, I just remember them easily. If you run this, you will get what you need. Also, you have a Docker image for Jenkins. So, for example, if you don't want to install locally Jenkins, you can have your own Jenkins instance with Docker container, and you can create your pipelines there without need to install anything. You can also get SonarQube locally, so you can also scan your code with SonarQube just by using containers. But there's a bunch of cool stuff there that you can get from it.
awesome. I'm really interested how you would create pipelines and Jenkins in a Docker container. But that could be something. That's probably something for the next round. But yeah, it's pretty cool.
Yeah.
All
I
right.
guess the last thing I probably have is I took a moment to go take care of something, so I might have missed it. In terms of extracting data and information from that Docker file, did you go over that, or did I miss that?
Extract data from Docker file. No, basically Docker file is where you don't extract. Basically, you just put the commands that you are going to execute in your contain. If I may say, in your new container. But do you mean?
The
Or maybe I didn't get.
maybe the question was how do you extract the reports that are generated when you run tests, let's say in your Docker container? How do you
Oh, okay,
take those
okay,
reports
Yeah,
and
thank you.
got it.
okay.
Oh, sorry, I didn't get the question. Okay, if we are running a pipeline in GitLab or Jenkins, and that tool allow us to run our code directly inside of the image, that's something really easy. We just assign there's a feature where you just point to where your files are located, your HTML report or stuff like that, and those will be published here in GitLab. If you say that locally, we just run the command copy. So basically, you can get files from your Docker container. Let me open that command.
That was a much simpler explanation and answer than I expected. That's so.
Yeah, so basically the cool stuff is that the new CI/CD tools um, has the feature that are support Docker. So instead of doing all the configuration, you just put the name of the image, and it's like it's running, I may say locally. Your code will run inside that container, and you don't need to. You just need to point to your report, and you will get it. If you want to do it that locally, there's a command. We used it. Give me 1 second. Can get it from here. It's this one. So you run this command from your local. This is the ID of the container, and this is where you want to get the files from. In this case, I'm getting the files
Oh,
from.
okay.
And then the dot mean that if you are located in this folder, then all of the files will be copied in that specific folder. So that's very easy. You just go here and copy what you need. Let's suppose you are running a Python framework. You execute it in the container. Once it finished, then you run this. You just point to your report here, HTML, for example. Let's suppose it's located in home, and this report will be copied to your directory here.
Wow. Okay. So that makes also with the CI/CD like a very easy way to script all that and
Exactly.
extract.
Yeah.
That's amazing. That's really cool.
Yeah. So that's the cool stuff that if you have a complex pipeline where you're doing performance and then maybe you are kind of data testing with Python. So you will first create your scenarios, execute manually, make sure you have all your versions. You do that manually. Once you get to know that this is working, then you push all your containers, I mean your images to Docker Hub, and then you can use them with GitLab or actually with Jenkins, any tool. And you will get your reports just pointing to the directory, and that's it.
Wow, that's wonderful. Thank you. You make
More
it
well.
sound like pretty easy to do. I feel like if I actually tried to implement this, it would probably get pretty hairy. Is there how
Actually,
difficult is it to get rid of the Docker containers?
oh, sorry for not mentioning that, but we will find a section
Okay,
here called, I just call it cleaning. We have 3 commands to do that.
cool.
This is
Okay,
for containers. We just do Docker stop. Once we stop them, then we can remove them. And the images, we can just remove them. And this is where we put the ID, and then we can clean all of the stuff we just
wonderful.
made.
Okay,
Cool.
thank you.
So then
Yeah.
you can play around and generate your images based on your needs. You
Okay,
push
that's what I was
that.
worried about.
Exactly. But yeah, I
Accidentally
didn't.
making Skynet is a concern.
No, thanks for asking, because at one point I was wondering why my computer was very slow and actually had like 35 gigabytes of images.
Oh,
So
wow.
I figured it out, and then I needed to go to these commands. Yeah.
Wow, no, that's awesome.
Yeah, so thanks for asking. That's
Yeah,
very important.
thank you, thank you.
Yeah, Emmanuel, thank you so much for this documentation. I'm going to
Mhm.
definitely copy and paste it into my cheat sheets that I have
Yeah,
in my
this is really
local. Uh-huh.
I would say when I started learning about Docker, I was kind of scary because it looked very complex. But once you get to know the Linux commands, I mean, actually moving inside containers, that's something pretty cool. And so I think playing around with the commands, you will get to the point where you just know them, and then it becomes fun. but it's not too difficult, to be honest.
I think anytime dealing with a command line, it can get kind of intimidating because it's very picky about what you do. But it seems like Docker has very, very clear commands, which is wonderful.
Exactly. Yeah, that's. I think I put on the link here. If you open useful links, I put it the link to the official reference, and here you will get all the commands with all the arguments and stuff that you can use.
Oh wow!
This
Okay.
is something. This is something that I will need to study or research Swarm. I've heard about it, but to be honest, I haven't dig into this. This will be my next step with Docker
That sounds
to learn.
intimidating and very dangerous.
Yeah, but yeah, I will give some tips. Remember, we were installing Maven and stuff like that. So if you Google for images, for example, you want Python, you just do Docker hub Python. I will go first with Alpine and try to check if we have an Alpine, because Alpine is very light in size. So I will go here, and you will get what you need. So if we open this, sometimes you will get the Docker file here. All of the images are based on previous images, so you get one image, then you put what you need, and you create a new one. So it's an image over another image, layers of image. So basically, you will have all what you need. You don't need to install too many dependencies sometimes. So if you need Jenkins, just put Docker hub Jenkins, and you will find an image for that. If you want SonarQube, and you will get all the details and how to run it. Here, the people that work on it, stuff like that. It will give you all the steps. So once you get familiar with the commands, you will easily get to reproduce your environment without issues.
Very cool. Very cool.
All right, guys. So I think that's it on my side. I really appreciate you guys having the time to join this meeting.
Thank you so much for presenting.
Yes, Emmanuel, thank you very much. It was very, very helpful. And actually, it was demystifying. I know that that's how I said there when I was sharing the link to this meetup. But it actually was, it kind of demystified some things for me. So I really appreciate it. Thank you so much.
Yeah, definitely. It's almost like if you can make a Docker container as a place for someone to work and learn about Docker inside of it without destroying right their whole operating system. This like this really allows for that kind of experimentation, which I think is really important and good for continuing your education and learning some type of new tech.
Exactly. That's a very important thing. I mean, if anyone wants to work on this image, they will not make any damage to the source code. So for sure, that's something really helpful.
It's like a really good tool for onboarding. It's like, here,
Exactly. Yeah.
here's the code base. You can't break anything.
And the new people will get to learn commands that are very helpful. And when you learn commands, you don't need to open a lot of applications.
Yeah.
You just do the commands, and you can update txt files, move them, delete them. That's pretty cool.
Yeah. Okay. Well, Thank you so much. Thank you everybody for joining. I hope you have a great rest of your day. It's really nice outside here in Kansas City, so if you
Yeah.
want to go for a walk, that's what I'm planning to do after.
Good idea.
Yes.
Be safe, Olga.
I will be walking really, really safe.
Thank you so much for this presentation. This was really cool.
Thanks, everyone. Have a good one.
Thank you.
Thank you
Bye-bye.
guys. Bye bye.
Thank you.
Bye.